All right, welcome back. What we're going to do is do 3 practice problems. So what I'd like you to do is turn to page 187 and do number 95, number 96, and number 98. Go ahead and push pause, do the problems, enter the answers, and then we'll go ahead and go over them. All right, let's take a look. So the first question is asking you to determine whether the answers, or the triangles are congruent, similar, or we just don't have enough information. So on number 95A, I'm going to go and take a look. I'm going to go and sketch them, just so I could reference them in this video. This is 120, this is 35, this is 35, and this is 120. I'm only giving you 2 pieces of information. And the 2 pieces of information that I'm giving you are that these 2 angles are congruent and these 2 angles are congruent. The only thing that you have now is angle, angle. Well, that's enough to show similarity. So we have angle, angle, similarity. All right, B. The triangles are disoriented, so what I'm going to do is reorient them so that they look like they're in the same position. So we have a 2 up top, we have an 80, and we have a 15. So I'm going to put the 80 up here. So if the 80 is up there, the 15 went down there. So far, we have angle, angle. And then if we look, there we have a 2 up here as well. So we have angle, angle, and a side. Well, angle, angle, side is one of our conditions for congruence. All right, and finally, I'm still going to use that same idea of reorienting the triangles so that they're in the same position. So this is 62, this is 62, and there's an 8 and a 5 where the 62 is in the middle. But on this one, the 5 is here and the 8 is down here. The 62 is not in between them. Since it's not in between them, I just don't have enough information. So I'll put not enough info. All right, let's take a look at number 96. So number 96 are a bunch of distribution problems. Now, I'm sure you've gotten comfortable distributing multiple ways. Feel free to do it any way you want. So we have 2x, 3x minus 4. You probably already distributed this problem like this last year. So this would be 6x squared minus 8x, done. And also last year when you did problems like this, you put them in a box. It's perfectly fine. If you did it another way, by just distributing, so this is 2x squared, 6x, negative 5x, and negative 15, combine like terms. So you've got 2x squared, this combines to 1x, you could just put x if you want, and a minus 15. It got a little covered right there. All right, for C, you have 2x plus 5, 2x minus 5. So we have 2x plus 5, 2x minus 5. So this is 4x squared, 10x, negative 10x, and negative 25. These cancel out, and we're left with 4x squared minus 25. This is actually a special case called a difference of squares. You might want to add that onto your notes just because it comes up quite often. So basically what we have is the same thing written twice, but just one with a plus, one with a minus sign. And if you look at your final answer, they're perfect squares, so that's why they call it a difference of squares. All right, and D, we have x, 2x plus 1 times the quantity x minus 3. Now we have 3 things being multiplied, so what I would do is just deal with 2 of them at a time. So I'm just going to deal with these 2. Slide that up a bit. Before you came into this class, again, you knew how to multiply this, just distribute it. It was 2 times x is 2x squared, x times 1 is x. The only difference is I'm going to put my answer in parentheses because I have more. of the problem. So I'm just going to write down the rest of the problem. Now it becomes a problem you already know how to do by using a box. And that's kind of a typical process in math. All right, go back to what you already know and do it in pieces. All right, so this is 2x cubed, x squared, negative 6x squared, and negative 3x. Again, combine like terms, and I'm left with 2x cubed minus 5x squared minus 3x. All right, go ahead and flip the page. I have to flip the page. Number 98. All right, 98 is just asking you to take this trapezoid and use a scale factor of 2 and then find the perimeter and area. If you didn't find the perimeter and area on this problem, pause the video and go ahead and do that right now. All right, so we're going to enlarge this shape. So I'm going to give myself a little bit of space here. I'm going to go over 3, 1, 2, 3. And then I'm going to go up 4, 1, 2, 3, 4. Over 6, 1, 2, 3, 4, 5, 6. And then this piece happened to be 5. I have a scale factor of 2, so what I'm going to need to do is just double everything. So instead of 3 here, I'm going to go across 6, 1, 2, 3. So this green triangle, or green line, is going to be 6. I've got to go up 8, so here's 4, 5, 6, 7, 8. And then I've got to go across 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to connect these two lines, or 2 points. I'm not really sure what that is. I'm guessing it might be 5, but anytime I have a slanted line, it could be something weird. So I'm going to leave it at that for right now. All right, so the first thing they want you to find is area and then perimeter of both shapes. So I'll just color code it. Area, that's a trapezoid, so it's going to be the height. Oh, dang it, I don't know what the height is. So I don't know what that is right there. Well, actually I do. It's 4, right? If I go straight across, there's 4, so it's going to be 4 times base 1 plus base 2 divided by 2. So 6, 7, 8, 9 times 2 is 18. And did they give me units? Nope. All right, so then we'll go with the perimeter. Just add up all the numbers. 3 plus 4 plus 5 plus 6. So that's going to be 18. Hey, they happen to be the same, huh? All right, next one I'm going to do in green. The area of the large trapezoid. Again, this is going to be 8, right, because that's 8, plus times 6 plus 12 divided by 2. So that's going to be 18. So I'm going to use a calculator so I don't mess this up. So we have 8 times 6 plus 2 is just 18 divided by 2, and that's 72. Oops, sorry about that. All right, and remember I said I wasn't quite sure what this was. It could be 10, it might not be 10, but I'm going to double check. So I have a right triangle here. This length right here is 6. This length right here, and I'm just going to redraw the triangle off to the side because I'm going to end up with too many numbers up there. So this top part is 6. I want to know what this is because I need that to find the perimeter. And this side is 8. So this is actually one of the 3, 4, 5, a multiple of a 3, 4, 5, or you could use Pythagorean's theorem. But this does come out to be 10. So it actually doubles this side too. So that's good to know. So now the perimeter is going to be 6 plus 8 plus 12 plus 10, which is going to be 10, 20, 36. All right, so now I have the area and perimeter of both objects. Now it asks me, what do I notice? What do you notice when you compare the perimeters, when you compare the areas? So if I look at the perimeter of this one compared to the perimeter of this one, how much bigger did it get? Well, the perimeter got twice as big. So the perimeter got 2 times as big. All right, let's look at the area. I wonder if the area got twice as big as well. And here's the areas. Well, it didn't get twice as big. It actually got 72 divided by 18. It got 4 times as big. Well, that's unusual, right? So the area, in fact, we took 72 divided by 18, which is 4, times as big. So if my scale factor was 2, my perimeter gets doubled and my area gets quadrupled. All right? If you have any questions, ask your teacher. Thanks for watching.